In this slide we're looking at rock falls versus rock slides. So a rock fall, it must be a cliff. You have large blocks below the cliff that may indicate the potential for a fall, and you can see where the rocks are just breaking and falling down the cliff. You can see them at the bottom of the hill to indicate this has happened in the past. A rock slide, you have a somewhat intact block at the start of the movement that starts to move as one piece. It detaches along the bedding plane, a fault, or some other discontinuity, and it moves downhill as one piece. You can also get a rotational slide. In that case, you have curved surfaces in either rock or loose materials. It's also called a slump, and it just rotates downhill. The rotation tilts the layers if there are layers present, and you can see how it sort of sloughs off the mountain, rotating down the hill. This is a better look at a rock slide where you have one detached piece that's moving as a mass. So what you'll find to see if this has happened, at the top we'll see it leaves behind a scar. It's also called a scarp. You can tell where this is because there'll be no vegetation there. You'll have a nice slope with vegetation, and then suddenly there's a drop or a cliff or an area that looks like it's been scraped off. There's discrete layers, joints, or fault surfaces where it's broken away. And then you get detachment along weak layers. So that's where our red arrow is. It shows this block moving along that detachment. And then a place to slide. It's working its way downhill to the lowest point in the valley where it can be stopped by gravity no longer pulling it down. And the leading edge overruns the land surface. So it's plowing over whatever it comes in contact with, taking out trees, overriding the river, just plowing over everything. These are examples of slope failure that involve flow as their mechanism of movement. The first one that I mentioned before is creep. The speed is very slow. It's a continuous movement in weak materials. It occurs mostly on slopes at varying rates, but usually slow and fairly steady. The next one down is a debris slide. This has unconsolidated materials, but it detaches along some interface. So it might be detaching along a bedding plane, a fault, or something like that, an area that's weak. And then the last one is an earth flow. We've got weak material with a matrix of fine-grained materials. It moves like wet concrete. It can also be called a mud flow. These can be very large and very dangerous. Continuing with the mechanism for movement of flow, this top one is a debris flow. In a debris flow you get loose slurries with various sizes of clasts that can move rapidly. And the bottom we've got a rock or debris avalanche. This is a collapse of a steep slope followed by high velocity flow. So you have shattered pieces of rock that get left behind. The images shown here represent actual events. In the top image, this is a debris flow that occurred in Venezuela, but the one on the bottom, the rock avalanche, was pretty huge. This was in Peru in 1970. An earthquake shook loose the entire side of a mountain and killed 18,000 people in one town. This example of a landslide is in La Conchita, California, which is a coastal California town hit by landslides, one earlier in the 1980s and then these two, one in 1995 and one in 2005. It's the same area or adjacent area with identical settings in both occurrences. Geologists have actually recommended abandoning the town at such an unstable location And this is an area that had, multi-million-dollar homes built at the base and on the side of the hillside that were put there for a great view, great location, which is pretty typical for us to do. Living on a hillside sounds ideal, but not in an area that is unstable. So the sediment in the area was prone to landslide in the first place, and people decided to build these very heavy houses on the hillside. So that was the first problem. Secondly, they undercut the slope as well at the base to build more homes. And then finally, the main problem is kind of gross, because these houses on the hillside were not part of the sewer system. They had their own septic tanks. Well, septic tanks where all of the waste from the household goes are prone to leaking. So not only is that a contamination problem, but it saturates the soil so that when it does rain, it's already a very heavy surface. The sediment is so saturated, it's so wet, it's already ready to slide shortly after the rain has started. So this is a particularly dangerous area where people continue to build still. I wouldn't want to know what their insurance rates are like now, though. Landslides are very common in California, but they're certainly not limited to California when it comes to the U.S. These are all examples from the U.S. The top left is looking at a debris avalanche in Alaska. This was a magnitude 7.9 earthquake that triggered this huge avalanche of earth in 2002. It unleashed massive rock and debris avalanches into this valley. The upper right-hand corner shows the Tully Valley in New York. This landslide was an earth flow in 1993. It mobilized clays and deposited it in a glacial lake. And then the bottom left-hand side, we're looking at Wyoming. There were tilted beds making up the landslide that were undercut naturally by a river. You could hear the mountain making sounds before the rock slide. That was written about when it occurred in 1925. And then the bottom right-hand corner, this is the Thistle landslide in Utah. This is the costliest landslide in United States history. It buried a railroad, 2 highways, and an entire town in 1983. So landslides are definitely a hazard to be taken seriously, to understand the mechanics, and to certainly avoid an area if possible. This map is showing us the potential for landslides across the U.S., with the red areas marking the highest potential for landslides, the yellow or green as intermediate, and then the unshaded areas as low potential for landslides, or areas that have not been studied for their potential risk. So observe which areas have the landslide potential and see what type of area do you live in. Try and come up with some generalizations about what type of areas have high landslide potential. So are there particular features that you notice that are aligned with these risks? So for example, we can see that there's a high association with mountainous areas, areas along the west coast where there are earthquakes, there's coastal erosion and heavy rain, areas along some rivers like the Mississippi where we have major flow of water coming through. That river can cut into slopes, or surrounding river terraces can give way as mass wasting. And then specific geologic units, like in the Colorado Plateau, closer to us, in the Dakotas, and in Texas, those areas are more prone to landslides. Identifying an area where landslides have occurred in the past is important for making sure that you don't build on areas that are prone to landslide, because if it's happened in the past, it can happen again. So some of those features to look for if you're trying to recognize prehistoric slope failures are hummocky topography, prehistoric deposits, rocks at an odd orientation, and rock types that do not belong. So hummocky topography is a type of chaotic landscape characterized by randomly distributed high and low points, humps and pits that are commonly created by landslides. Prehistoric deposits. You're looking for debris flow deposits. So it's going to be poorly sorted, very large class along with small class. Rock types like breccia are really common. Rocks at an odd orientation. Here you're looking for rotated blocks. So you can see in this image from the Theodore Roosevelt National Park in North Dakota that all of the layers used to be horizontal, but this huge block has now been rotated down and forward along some rotating surface. And then the bottom right, the exotic rocks, you can see that the rocks have been brought in from another area. Along with those features, there are other things to look for in assessing potential for slope failure or trying to figure out if an area is prone to these type of slides. So you want to see if there were past failures. This image is showing us active failures in Nepal. So where it looks like the vegetation has been scraped off, those are areas where the slope is failing and sediment or rocks are sliding down the hillside. So we know that that is not a safe area. There's a potential for slope failure for sure. Known problems. So this image is looking at adjacent areas in Yellowstone. They have the same setting as a slope that failed nearby. So if you've had a landslide in that rock type in one area, you're likely to get it in the same rock type in another area. Steep slopes. This is an image from the Italian Alps. This steep area is uncovered by melting of glaciers. So the glaciers cut through the rock and created this very steep valley. And now as the glaciers retreat and melt, those valley walls are susceptible to slope failure. Changes in slope. This is in Switzerland. One rock fall changed the slope and unleashed a larger rock fall. It's almost like you took the cork out of a bottle. One rock was holding the rest back. That triggered a slide. That rock slide buried 31 houses beside a highway and a railroad. So something as simple as a rock fall can lead to a bigger problem. Conditions of materials. This is looking at the Green River. These layers of rock are gently dipping with vertical joints that are parallel to the cliff. So because they're parallel to the cliff, that allows them to move more easily. So the same layers in the background that are gently dipping in the foreground are tilted toward the viewer with inclined joints, not parallel to the cliff, but layers parallel to the slope. So wherever it's parallel to the slope or parallel to the cliff, it's easier for those rocks to break apart and move along that slope or that cliff just due to gravity. And then finally, potential triggers. This image is of the Augustine volcano in Alaska with dark rock avalanches occurring. If you're in an area with volcanic activity, with seismic activity, then these are all potential triggers for landslides.